welcome to another lesson. I'm going to start this lesson by saying that you should watch this video that you're looking at right now. This is a really nice video, kind of giving you a nice overview of defining sets, what they are, how to set them up, what they mean, all sorts of stuff. Kind of in the same vein as the videos I've shown you before with that weird professor guy, von Schmohawk, or whatever his name is. So yeah, it's only 5 minutes and a half. Check it out. Follow the link in your notes and check it out. This is coming, by the way, right off of set builder notation. So at the end of page 14, you go into page 15. Watch this video. That's what you should do first. Once you've done that, we're going to move on to properties of sets. And mostly what we're going to be covering today actually is what's called subsets, which is when numbers or elements of one set can be found in another set. But we'll get to that when we get to it. First, let's go through some basic properties of sets. Two things that you should be aware of: the order of a set and the repeated elements in a set. What I mean is the order of the elements within the set doesn't matter. What does it mean to have the order of the elements? Well, look at this set here and look at this set here. A is 1, 2, 3. A is 3, 1, 2. They are the same. Okay, so the order, what it means is literally the way that you write the numbers down doesn't matter. Just like if you had the set B equals 4, 6, and 5, it is, of course, the same as if you wrote the set 6, 5, and 4, and it would be the same as if you wrote the set 4, 5, and 6. Any combination of those numbers are all exactly the same. Okay, so that's the first thing I'll bring up. They are literally the same set. The second thing I'll bring up is if you have a repeated element, it's the same as if it was listed once. So when you look at a set, if you have a lot of repeated digits, it's almost like idempotency in Boolean algebra. But you have repeated elements, they don't change the set. They don't change anything. It's like saying you have 100 blue shirts. Let's make a set of all the possible shirts you have in your closet. Okay, I have red shirts, I have blue shirts, I have green shirts. Well, who cares if you have 100 blue shirts and 50 green shirts and everything else? Like, ultimately, you have red, blue, and green shirts. Because if we're dealing with categories, we only care about the category, not how many you have of each category, okay? So what it means is you can essentially cancel out the extras, and you end up getting the same as if it was written as 1, 2, 3, and the same as if it was written as 3, 1, 2. All right? So repeated elements don't matter, and the order doesn't matter. So the first two exercises here are going to help us understand how this applies, and they're kind of in a practical sense. It says, rewrite each set by removing the repeated elements and writing them in numerical or alphabetical order. So if they're numbers, we'll write them from smallest to biggest. If they're letters and numbers, we'll write it in the logical way, smallest to biggest, A to Z. First things first, this first set, I see a lot of numbers, but there's a lot of them repeated. So I have 3. I'm just going to look at the first letter I see and see if I see any other 3s. So I see a 3. Any other 3s? Yes. Cancel this one. Cancel, cancel. Let's do the next thing for 4. I see another 4. I see another 4. What about 5s? I see another 5. I'm going to go over to the 2s. Let's see I have any other 2s. Yes. I'm going to cancel those out. What do I have left? 1s. Cancel the 1s. And I'm done. So I have 3s, 4s, 5s, 2s, and 1s in this set. So you can rewrite it. You want to rewrite it first and see if you get the same thing as me? What are you going to write? You have the number 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. I told you that the order doesn't matter, and it doesn't. So this is the same as if you just threw the numbers 4, 5, 3, 4, 5, 2, and 1 into a set. But I've asked you to write them in numerical order, which is just keeping our work organized. So that's why I gave you that answer. What about the next one? Pause the video, give the next one a shot. What you should get is this. Hopefully you'll agree with me. I'm going to check my work just in case. I put the numbers first, because usually numbers come before letters. It's just common practice. But if you put the letters first, it's no big deal. It's still correct. As long as you have the right elements, you're correct. So let's see, I have C. Let's cancel out any extra C's. I see a couple C's. I have an E. I'm going to cancel any other E's. Okay, there's no other E's. G. Cancel out G's. All right. A. Cancel the rest. I've got a B over here being sneaky, so let's not forget about that. Now we're into numbers. Threes. Do I have any other repeated threes? Yes. What about 2? Yep. And 1s? Now I should either have all things circled or all things crossed out, which means I have my unique elements and no repetition. And they're all in a weird order, so I'm just looking at my numbers, which is why I said 1, oops. I said 1, 2, then 3. That's all my numbers accounted for. And what about my letters? I have A, B, C, there's no D, E, and then G, which is why I have all these. Okay, so it looks like I'm correct, and if I made a mistake, you gotta let me know. Let's move on. What does it mean for sets to be called equal, equivalent, or disjoint? Well, I'll just set the scene right here for you. 2 sets are equal if they have the exact same elements. So for example, D equals ABC is, sorry, let's go to this one. I don't know why they're in weird order. X is 1, 2, 3. It's equal and equivalent to this. How is it the same? It's because it has the same exact elements. 1, 2, and 3. 1, 2, and 3. The rest are just extras. Okay? They're exactly the same. So I kind of jumped ahead a bit. What does it mean to be equivalent? So 2 sets are equal. What about if they're equivalent? What does it mean to be equivalent? It's if they contain the same total number of elements, but not necessarily the same elements. So D equals ABC. This has 3 elements in it. Once we cancel any extras, which there are no extras here, which is nice. Is equivalent to E equals red, green, and blue. That has 3 elements. So if they have the same total number of elements, they are equivalent. They do not need to be the same. They just need to be the same number of them. Okay, so what's the difference now between equal and equivalent? Equal means literally the same set. Same number of elements and the same exact elements themselves. Equivalent just means the same size. Right, just the same number of elements, same size set. Finally, what does it mean for sets to be disjoint? It means they're disjoint if there's absolutely no common elements. So they can still be equivalent, but be disjoint. Okay, what do I mean by that? You have the numbers 1, 2, and 3 in the first set. You have the letters A, B, and C in the second set. They're disjoint because none of the elements are the same. However, they are equivalent because they have the same number of elements. All right, take some time to let that process, and we're going to move on to some practice. So pause the video, make sure you understand this page, and then you'll be well prepared to do the next page. The next page is some practice. It's going to ask us to state whether the pair of sets is equal, equivalent, or neither. And in some cases, it can be more than one of these things, actually, so it's a little bit of a misnomer to say one or the other. So I'll add that in here. So I really should say and or. Okay, so try this practice. All you need to do is put check marks in, okay? So put check marks in to what you think is correct. The next page has the answers, but I'd like you to check it yourself. I'll do a few of these for you just to set the scene, but I'm not going to do all of them. So the first one. A equals 1, 3, 5, 7. B equals 2, 4, 6, 8. Well, they're definitely not equal because they don't have the exact same, it's not the same set. But I would say that they're equivalent because they have the same size. What about the next case? 1, 2, 3, 4, and so on. And then B is 1, 2, 3, 4. Well, they're definitely not equal, and they're definitely not equivalent because they're not equal. They don't have the same elements because look, this is a and so on. It's going to include 5, 6, 7, 8, 9. B is just 1, 2, 3, 4. So this is neither. What about the, let's see, let's look for an interesting one. Is there one here that has repetition? Let's see. Yeah, let's try number 4. The set A is 3, 2, 3. The set B is 2, 3. Well, really, the set A is the set 2, 3. Because they have the elements 2 and 3, and that's it. That's the exact same thing as if we just had the set B. So they're equal. Now, something interesting about equal sets are equivalent because they have the same size. So I'm going to say also same size. So you essentially get a 2-for-1 deal. Anytime you have a check mark, you're going to put it into the next column as well, because any equal set must, by definition, also be equivalent. Okay? So I put that note down here. I'll just get the full page up. Equal sets are also equivalent. That's why I have that special case here. I'll just put a little star there, and 4 is going to have a case like that, and there are a few others. In fact, anytime you have equivalency, you're going to have, anytime you have an equal set, I should say, you're also going to have an equivalent set. All right, so take some time to fill out the table, really give it a shot, see if it makes sense to you, and see what we get for the next one. Oh, by the way, it says if neither, state whether or not they're disjoint. I almost forgot that. So we had a neither case here. Are they going to be disjoint or not? What does it mean to be disjoint? It means they have no elements in common. So we can say not disjoint. And it's not disjoint because they do have elements in common. Okay? So on the next page, it's got whether they're equal, equivalent, or neither. And I'll just say if they're disjoint or not. Okay? I'll just add an extra column D, and I'll put a check mark or not for the neither ones. Okay? So the first case, they are not disjoint. For the third case, they're not disjoint. They have elements in common. And for the 8th case, once again, they're not disjoint because they do have elements in common. Some of these, I believe, are disjoint. If you look at it, yeah, for example, this case is disjoint because none of the elements are related. And in fact, the first case too is disjoint. So you might want to make your own column of disjoint or not, just to gain some understanding of this. But I'm going to move on from this. Now this is a nice topic, sets and subsets and proper subsets. And I've put a little diagram here, and if you understand the diagram, it should come pretty naturally to you what we're going to talk about. Essentially what it means is if we had, for example, the set B, which has elements in it, who knows what it is, it could be all the colors of the rainbow, and maybe set A is all the shirts you have in your closet. Maybe you only have red and blue shirts. Well, for example, red and blue shirts could be in set A, but all the other colors of the rainbow, you know, there's red, there's also orange, there's also yellow, there's also green, there's blue, and then there's indigo, and then there's violet, right? If you're just going at the basics. So B could be all the colors of the rainbow, and A is a subset of those colors. They're just the ones that you have in your closet, for example. But that's just one random example, okay? There's many, many, many cases of subsets. It's like your name, the letters in your name are a subset of the alphabet. Subsets. A set is a subset of another set if all its elements are contained in the other set. So in order to write A is a subset of B, this is the symbol that we use. So I should probably just leave it at this. Is a subset of, the special symbol, is this C with a bar underneath it. It means A is a part of B. To write not a subset of, we put this symbol. It's the subset symbol C with a cross through it. So the example says, determine two relationships between the following sets using the subset symbol or the not. So A is the set AB. B is the set B. Can we say something about their relationship in terms of subsets? Well, B is inside of A. Right? If we had our situation here, for example, we have a little diagram A, and this is our B set inside. Well, we could say that A is in the set and B is in the set, and then you'd hopefully see that if we look at A as a whole, that's AB, But we look at B on its own, it's inside of A and it exists. It can exist on its own. What I'm trying to say is B is definitely a subset of A. Okay? B is a subset of A. As a fact, for sure. What other situation could we look at? Well, we could say A is not a subset of B. Because if you take time to think about it, A doesn't exist inside of the set B. B exists inside of the set A. Right? We can't say that our shirts, our red and blue shirts in our closet, the colors of the rainbow aren't chosen from our closet. The closet shirts are chosen from the colors of the rainbow, if that makes sense. So if you can make a little group from your set, then you can make a subset. It's just a regrouping of the things that you've been given. So determine the relationship between the sets. Let's look at the relationship in this case here. We've been given the set A is 1, 2, 4. We've been given the set B is 4, 3, 2, 1, 5. And it even gave us a nice diagram here if you want to look at the diagram. What can we say? Well, just from the diagram, I can see that A lives inside of the set B. So A is a subset of B. That's all you need to write. You can write it out in English as well if you want. Let's go on to the next one. X is the set of letters A, R, E, and Y is the set of letters R, E, A, D. Well, the bigger set, R, E, A, D, read the letters R, E, A, D. You could rearrange them and make the letters in the set X. Looking at this diagram over here, it looks like the letters in the set X are a subset of the letters in the set Y. So we put the subset first, right? X is a subset of Y. And again, you could write that in English if you would like. What about P and Q? P has the numbers 1, 3, 4. Q has the numbers 2, 3, 4, 5, 6. But look at the problem here. 1, 3, and 4. Well, we have 3 and 4 in the set Q, but we don't have the number 1. So P is not a subset of Q, nor is Q a subset of P. Notice one is not inside the other. And if that's not the case, then it's not a subset. So you can say that P is not a subset of Q. And hopefully it can make sense to you why I'm saying this. It's only a subset if it's fully contained in another set. If it's not fully contained, then we can't call it a subset. So I hope you're seeing what I mean when I'm talking about this stuff right now. We're going to soon be building many, many, many subsets, and you'll get a better concept in your head about how to do that. But I just want you to get the general idea right now. And the next thing we're going to talk about is what's called a proper subset. So let's see what the difference between a subset and a proper subset is. Proper subsets, given by this letter C, there's no underline, are all subsets that are smaller than the original set. So smaller than the original set. Maybe I should just highlight smaller as the big important term here. Let's look at an example to immediately try to make sense of this. Suppose the set A is 1, 2, 3. Is the set 1, 2, 3 a subset of A? Is it a subset? Does the set 1, 2, 3 live inside of the set 1, 2, 3? Well, actually, yes, it does. It might seem weird, but we can make a subset from those numbers. That is the set itself. There's nothing really wrong with that. You can say all of its elements are contained in the original set. So what I mean, just say you have the colors red, green, and blue. Okay? You've been given the colors red, green, and blue, the set of numbers, or the set of colors red, green, and blue. And you want to paint a picture, and you use the colors red, green, and blue. You've used the original set. You could also say that you've used a subset. The problem is it's a subset. It's not what's called a proper subset. What's a proper subset? A proper subset is a subset that's smaller than the original set. So in this case, is the set 1, 2, 3 a proper subset of A? We'd say no. And do you know why we say no? Think about this. Proper subsets are subsets that are smaller than the original set. Well, 1, 2, 3 is the original set, so it's not missing any elements, right? So all of its elements are contained in the original set, but it's not smaller than the original set. And I hope that makes sense. We're going to start building the subsets, and I think you can make some sense of it, but hopefully it's not too confusing. And just before I move on from this slide, I want you to take a look at what I've said here. Try comparing this C symbol to the less than symbol, and try comparing this C with an underline to the less than or equal to symbol, especially paying attention to the underline, okay? The underline suggests that there's some sort of equalness, there's some sort of equality, or it means it's equal to. So when we have the subset symbol, let me just write this. If it's a subset, it can be less than or it can be equal to the same size. If it's a proper subset, we do not have that line. It must be less than in size, but not equal to. So it might be a good idea to write that down just until you really get it in your head what the difference is. Okay, write it down as a little bit of a reference for you. So let's talk about one more type of set, and then we'll talk about how many subsets something can have. The empty set, also known as null set. There's a little typo there. These are the symbols we're going to use. We're going to use a 0 with a line through it, and we're going to use a set of brackets normally used for sets, but it has nothing in it. Okay? First of all sets contain what is known as the empty set, also known as the null set. The empty set is represented by these symbols. 2 curly brackets with nothing inside of it, or a 0 slash. And once again, all sets contain the empty set as a subset. So let's consider this with the help of some fruit. Okay, it says in this case we have the set A, okay, the set A, which is apple, banana, mango, orange, peach, and plum. If we were to remove all those elements, so we take away the banana, we take away all the fruits, we just get rid of all of them, what are you left with? You're left with nothing, but you kind of have what's called an empty set. You almost have a space where your fruits used to be, but they are no longer there. So we can say that A, if you remove all the elements from inside of it, it's still a set, it's just an empty set. You've kind of like taken all the people out of the house, but your house still stays there. So it's a weird concept that you have an empty set, but it's almost like saying 5 minus 5 is 0. Well, if you say 5 minus 5, you don't just erase it off the page normally. You got to say that there's 0 there at some point. This is kind of like the set equivalent of that. You end up getting this empty set. You can also say A equals 0 with the line through it. But an important thing to note is that it is not A equals this. Okay, you've got to use one or the other. You either use this or this, but please don't mash them together because that's not proper notation. So this whole slide, this whole page, was to remind you that there's such thing as the empty set, and it exists as a subset of every other set. So we're going to start building this, okay? Because I'm going to ask you to start listing the subsets. And it takes a long time for something with a lot of elements, so I'll keep the sets small. What if someone was to ask you how many subsets a set has? Well, the first thing you would say, and you should write this down, this is a very important reference. A set with n elements has 2 to the power of n subsets. This includes the empty set and the set itself. Let me show you what it means. How many subsets does the set A have? Well, in this case, we would say n equals 3 elements. It's the number of elements in the set as you see them. 1, 2, 3. It just happens to be the numbers 1, 2, 3, but it has 3 elements. How many subsets? You could say the number of subsets equals 2 to the power of n, which is also 2 to the power of 3. What is 2 to the power of 3? It's 2 times 2 times 2, or 8. So you might not know what the subsets are, but you can tell someone how many subsets there would be if we use that rule. Okay? Now it's going to ask you to list the subsets. So I'm going to do this in the most logical way possible. I'm going to keep track of the empty set, and I'm going to keep track of the 1 element sets. I'm going to keep track of the 2 element sets, and I'm going to keep track of the 3 element sets. Just so that we have a structured way to approach this. And let me show you what I mean. All the subsets are the empty set. How many different sets can I make based on those numbers? I can say a set which is just the number 1, a set which is just the number 2, and a set which is just the number 3. I can also make 2 element sets. I can make a set that's just the numbers 1 and 2. I can make a set from the combination of the numbers 1 and 3. And I can make a set from the combination of the numbers 2 and 3. Hopefully you can see where I'm getting this. I'm looking back at this set and just combining the numbers into their own combination of sets. Finally, a 3-element set is just going to be the set itself. 1, 2, and 3. And let's check and see how many sets we have. We have 1, 2, 3, 4, 5, 6, 7, 8. When I counted them, I got 8 subsets, which is no surprise really, because it's telling us that I should. Let me show you an example with a larger set of data. This website is called Huo's Coding Lab, and it's a subsets generator, all right? And it will take any set. So I'm going to put in the numbers 1, 2, and 3, and I'll generate the sets. It says the empty set, and the set 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. That's exactly what I did by hand. But what if you had a bigger set? What if you had the numbers 1, 2, 3, 4, 5? How many subsets would that give us? Well, that would be 2 to the power of 5 subsets. 2 to the power of 5 is 32. There'd be 32 subsets. All right, if I generate this, it's going to give me 32 different sets. That's 32 sets. 1, 2, 3, 4, 5, 6. All the different combinations, and you can take some time to look at that if you want. Let me make it a little bit bigger. Make it full screen. Okay, that's 32. What happens if I had like a set of 10? Or like all the different letters in the alphabet, right? A, B, C, D, E, F, G, H, I, J. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different elements. 2 to the power of 10 is 1,024 subsets. Are you hearing this? 1,024 subsets. And those are the unique subsets. So think about all the words you can make just from those letters. Now, I know there's only a couple vowels in there, but like, it should come as no surprise that you only need a few letters to make hundreds and thousands of words. Let me click generate. I'm going to get 1,024 subsets right now. So give it a minute. It's going to take some time to process. It's doing all the combinations. Oh, there we go. So let's start at the beginning. You want to read this? You want to read these out? Well, I'll give you the structure. The empty set, all the different unique 1-element sets, all the different unique 2-element sets, all the different unique 3-element sets, all the different unique 4-element sets, 5-element sets, 6-element sets, 7, 8, 9, and then your 10-element sets is the set itself. So this kind of gets out of hand really quickly, and you can kind of have some fun making big sets, but the concept is that we can know how many subsets a set has, without having to actually write them all out. Maybe as a bonus on a test, I'll have you write out a 10-element set in all its subsets. Would that be fun? No, that would not be fun. Let us continue. How many proper subsets can a set have? Well, this one's easy. If we know how many subsets a set can have, we just need to subtract 1, because it just can't be the set itself. All right, so the set with n elements has 2n, to the power of n minus 1 subsets. So the minus 1, it says we subtract 1 from 2 to the n to make sure we don't count the original set. That's all we need to worry about, okay? So example, how many proper subsets does Q equal ABC have? Well, first of all, you need to write down how many elements it has. In this case, it has 3 elements. The proper subsets is going to be 2 to the n minus 1. Now, notice, this is not 2 to the n minus 1. It's 2 to the n, and then you take that answer and subtract 1. There's a big difference. Right? This one's correct. So what's 2 to the n? It's 2 to the 3, 3 being our n. And we're going to subtract 1. That's 8, the number of subsets we would have. Subtract the set itself, we actually have 7 proper subsets. And now it says list all the proper subsets of Q. Well, this is going to be a familiar exercise. You can write out the empty set. You can write out all the 1-element sets. I'm going to write it all in, I was going to write it all out in one line, but I should really split them up. So the empty set, then you have the 1-element sets, A, B, and C. And then your 2-element combinations. Just try to apply yourself in a logical way. So go in alphabetical first, A and B. And then try A and C. And then go alphabetically to the next possible combination, which is going to be B and C. Just make sure you check your work to make sure that you haven't, repeated the letters. Because if you did B and A, you'd be repeating the set AB, which is not good. And then what about the set ABC? That's a 3-element set, isn't it? Wouldn't that be okay? Isn't that the same as before when we did 1, 2, 3? Well, let's check and see if our formula tells us the right answer. Let's count. We need to have 7 proper subsets. 1, 2, 3, 4, 5, 6, 7, 8. So there's a problem. There's an 8th. Well, if you've been paying close attention, it shouldn't be a surprise that we're not allowed to include this. ABC is not a proper subset because that's the set itself, and we don't include the original set. And that's super important. All right? So hopefully you're clear as to what the difference is between a set or a subset and a proper subset. And the big difference is that proper subset just doesn't include the set itself. So the next section is just practice. And I'd like you to just pause the video, work through the practice section, and then I'll start putting out the answers. All right? So pause the video, try the practice set, and then I'll list all these answers here. Okay, so I just went to check that I had 8 subsets in this case, and I did. So I'm going to move on. Okay, this is a 4-element set, so it's going to be much bigger. So it'll take a little while, but not the end of the world. We just got to take a little bit more time to do it. Okay, so there's a few ways that you can check this. You can count them all out, and I'll just do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, 15, and I've got 4 elements. So it might be a good idea just to write down a little check. You've got its proper subset, so 2 to the power 4 minus 1. 2 to the power 4 is 16 minus 1. That will give 15. So I just double checked and made sure that that actually was the proper number of sets I've written down. And another important thing is make sure you don't have any duplicates. So I try to write it down in the most logical way that I can. I can see here maybe I've made a few interesting choices. For example, starting with my ones and then I skipped one. But hopefully I haven't made a mistake as I went. And as long as you have the exact same sets as I do, the order doesn't actually matter. Okay, so that's an important thing to keep in mind. Let's keep on trucking. Let's do this last page. How many proper subsets will that set with 8 elements have? All right, I'm going to do this whole page. I actually don't need to talk through this. You just need to note that this is proper, the next two are subsets, and this is a proper. So they just have slightly different rules. If you keep that in mind, you'll be fine. There you have it. These are the answers that I came up with. Hopefully I didn't make any mistakes along the way. And hopefully you were able to do that yourself as well. It's really important that you get that practice. The last thing I'll suggest that you do is to take 4 minutes and watch this video on equality and subsets. It's a really good summary, I guess, of what we covered today in this video, and is just a little different way of looking at it and a little bit more visual in terms of, animation, things like that. Okay, I hope you enjoyed this video. I hope it made sense to you, and I will see you in the next one.